Hey everyone, let's do this newest assignment in Desmos. It's titled Intense Integer Madness. And I've already got problem one up on the screen. It says, convert this equation to all addition by adding the opposite, draw a vector model, and find the final position, which would also be the right side of this equation. So we got a lot of work to do on this one. So what I see is -10 minus 4 plus 8. And so the only place in this equation where I said the word minus was right here, this symbol. And so if I'm going to change subtraction to addition, that's where I need to do my work, right? So -10 is going to stay -10. But -4, that's where I want to add the opposite instead of performing the operation of subtraction. So instead of -4, I'm going to add -4. Okay, don't just switch to +4, right? You can't do that. You can't take a -4 and just turn it into a +4. If you change minus to plus, then the way you even it out, right, because you're changing the operation, is you have to change the sign of the next number. Or what I like to say is invert the next number. If it was opposite, if it was negative, it becomes positive. If it was positive, it becomes negative. So in this case, that +4 became -4. And then the last piece is +8. And so if we're going to draw a vector model, we always have to convert to addition because you can't really do subtraction in vector models, at least not really a way that I can think of to do it. So now we've got our equation all written in addition, so we can draw a vector model here. I'm going to use the Desmos drawing tool here, and maybe I'll scroll up a little bit. I don't really think it's necessary to draw all these different lines, like like -1, -2, -3. That seems like too much work in my opinion. But I want to be strategic about where I make my lines. I look at the first number, I see it's a -10, so I know I'm going to need to go to the left 10 spaces. And then the next thing I see is a -4, so I'm going to need to go 4 more spaces left from there. And the last thing I see is +8, which is going to bring me 8 spaces back to the right, but not all the way back to 0. So I'm already thinking ahead for my vector model. I'm never going to cross a 0 on the positive side. So I might as well make the 0 all the way over here. And then, I don't know, all right, maybe I'll make 14 little dashes because I know I'm going 14 spaces to the left. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15 just for fun. Probably don't need to label every single one though. That would be super messy. So I'll label every 5. So -1, -2, -3, -4, -5 is right here. And then -6, -7, -8, -9, -10 is right here. And -11, 12, 13, 14, 15, -15 is right here. All right, now I'm ready to draw my first vector. It's going to start at 0. And it's going to go 10 spaces to the left. Wait, which one's -10? I lost track. 6, 7, 8, 9, 10. It's this one over here. Okay, then I start my next vector where the previous one ended, but just a little bit above, so it's not messy. And I'm going to go 4 more spaces to the left. And then the last thing I see is +8. So I'm going to go 8 spaces to the right. Anytime I change directions, I personally think it's easier to count before I start drawing because then I'll know where I'm going to stop. So let me start here, and I'm going to count 8 spaces to the right. And don't make the mistake of counting the space you start on. Don't go 1, then move and count 2. You'll always be off by 1 if you do that. You have to actually move a space before you count a space. So 1, 2, 3, 4, 5, 6, 7. Right here is where I'm going to stop. Wait, no, I only counted to 7. I meant to go to 8. So 8. Right here is where I'm going to stop. So I'm just going to kind of like put an arrow to tell myself to stop there. And I'm pretty sure that that's -6, right? Because it's one space over from where I labeled -5. So I'll label that as -6. I'll draw my vector to stop there. I should also label my vectors. This is a -10 vector. This is a -4 vector. Label the vectors with the numbers that they represent, not the numbers that they end at or the numbers that like the problem is going to equal, just the numbers from the problem that you're representing with each vector. And so this one's going to be 8. The answer here is going to be this -6 that I can see here. And so I think we're done. This stuff here, where I changed it to addition, you might want to write that in your Desmos box here. I wrote it on the screen using Zoom tools, but I guess in order to show your work, maybe you should put it here. And then it looks like the answer is going to be -6. And I think we're good. All right, let's move on to the next one. And look at the following two equations. Write the answer below for the equation that should be negative. Below, write the answer below. This is written kind of strangely. There's typos here. Okay, below, write the answer below for the equation that should be positive. Then explain the difference between the two equations. Okay, so look at these. The top one is multiplication and the bottom one is addition. But other than that, the numbers are the same, right? -6 times -3 and -6 plus -3. One of these is going to turn out positive and one of these is going to turn out negative. And the reason me and Mr. Wong chose to put this question in here is because we want to make sure that you're keeping your multiplication rules and your addition rules separate. When you start learning both or you're reviewing both, like we have been in class for the last month or so, it's really easy to start getting these things mixed up, especially a lot of students like to memorize this thing in their head where they say 2 negatives make a positive. And that's true for multiplication. And that's why this top one equals +18, because -6 times -3 is +18. But two negatives definitely don't make a positive when you're adding them. If you have -6 and then you add 3 more negative, think of it as your submarine, right? Your submarine's already at -6 in the Desmos activity, and then you add 3 more anchors on because anchors are negative numbers. That submarine's just going to go down more and wind up at -9. So let me put these in the boxes where they go. This one should be -9. And this one should be +18. And so we're supposed to explain. I'll put this in my own words. You might have your own way of putting it. When mole, I don't know why it's not letting me type. There we go. Multiplying two negative numbers always results in a positive product. The product is the number you get when you multiply two numbers. So that's kind of like just saying you get a positive answer. And then when adding two negative numbers, the sum, right, the number you get when you add two numbers is just more negative. Cool. I'll put that big back on the screen in case you're copying it. There you go. All right, so this one's another sort of the same thing. This time we have division. Remember that fractions just are another way of expressing division. Think of the fraction bar here in the middle between the 28 and the 7 as just being the same as a division sign. So this says 28 divided by 7, but with a negative sign out in front. So you do 28 divided by 7, and then it's the negative version of that. And then this bottom one has a bunch of subtraction and negatives in it, right? This says -7 minus negative 28. And so according to the instructions here, it looks like one of these should turn out negative and one of these should turn out positive. Well, I'm pretty sure the top one's going to be the negative one, because what we're really doing here is 28 divided by 7. Oh, I didn't mean to do that. And then just sort of like keeping the negative sign with it, right? So the negative sign is sort of like out separate. Do your 28 divided by 7, which is 4. But then you got to keep that negative sign. So the quotient here, what you get when you divide two numbers, is negative 4. Or you could think of it as like the value of that fraction is negative 4. So the other one's, in my opinion, a little more tricky. We have negative 7 minus negative 28. Well, I like to think of subtraction as adding the opposite. When I read this out loud, this sign right here was the only one that made me say the word minus, and so I'm going to change that to plus. But I'm not allowed to just change a minus to a plus without inverting the next number or making the next number the opposite of what it used to be. If you just change a minus to a plus and don't change anything else, you're going to get a wrong answer every single time. So this negative 28 is now going to become positive 28. And so essentially what happened is that minus negative, those two signs were right next to each other, these two right here, they became a plus symbol. And so this is another time when people like to say, oh, two negatives make a positive. And that's kind of true here. But see how it wasn't true when we added two negatives earlier? And so that's why it's important to like keep these things straight of like when does this happen and when does this not? All right, so we have negative 7 plus 28. The way I like to do these is I just turn them into subtraction problems. I go 28 minus 7 equals 21. And then I look back at the original problem before I like just turned it into subtraction, and I see which number had greater absolute value, or in other words, which number was bigger if you don't think about the negative signs. Well, the 28 is bigger than the 7, and it was a positive number, so that means the answer is positive. So it's going to be positive 21. So here we'll put a negative 4. Here we'll put positive 21. And then explain how I calculated negative 7 minus negative 28. Well, I think the most important part of how we calculated this is subtracting a negative number is the same as adding a positive number. I mean, there was more pieces to it that we did, but that was like the main, most important piece in my opinion. So I think that's, for me, that's a good enough explanation, just explaining that we essentially changed a minus negative 28 to plus 28 over here. And then I used sort of a funky strategy that involved subtraction to solve it. So there's like a bunch of different adding and subtracting things going on here. All right, let's move on to the next one. All right, find the matching equations, problem 4. Select all of the expressions that are equivalent. Well, what if I'm finding expressions and I'm not really matching equations, am I? They're expressions. Oh, well, I'm being nitpicky. All right, so we want the ones that are equivalent to negative 1/2 times negative 16. So when you're multiplying fractions, sometimes it's easier to replace the multiplication sign with the word of in your head, and then it's easier to find the answer. Like, what is 1/2 times 16? That's the same as 1/2 of 16, and I know that's 8. So if I know 1/2 times 16 is 8, then the only other thing I have to worry about is remembering my positive and negative rules. Here I have a negative times a negative. That's a positive. So the value of this expression is positive 8. So now my only job is just go through here and select the ones that also equal positive 8. Well, I'm not selecting this one because 2 times negative 4 would equal negative 8. So I'm not selecting that one. 2 times positive 4 is positive 8. So I would select this one. All right, -1. So when you have to do multiple multiplications, or you have like more than two factors, and some of them are positive or negative, positive and negative. For me, it's I just do them from left to right, and I keep track of them as I go, like which one's positive and negative. But there's another trick you can use too that I'll talk about. So step one would be to do -1 times 2. That equals -2. Then I'm going to take that -2 and I'm going to multiply it by this -4, and that does equal +8. So I would select that one. Another little trick you can use though is when you're going to multiply or divide like a string of factors, if you count up the number of negative factors, like in this case, we've got 1, 2, since there was a even number of negative factors, the answer came out positive. Had there been an odd number of negative factors, the answer would turn out negative, because every two negative factors sort of like cancel each other out and make a positive. And so if it stays even, they're all canceled. But if there's that one extra making it odd, your answer turns out negative. All right, here we've got 1/8 times 32, -1/8 times -32, I should say. So the answer to this one's going to turn out positive. But what is 1/8 of 32? That's 4, not 8, so I'm not selecting it. And the last one, this is the negative version of 16 divided by 2. That's the negative version of 8. It was -8. I don't want that. So, oh, look, the answers have been here on the screen the whole time. Those are the only two we should select. Those are the only two we did select, so we're good. I want this off the screen. I don't want to show the answers the whole time while I'm working. I want to force you to watch and listen to me to get the answers. Okay, which expression has greater value between these two? So both of them are subtracting a negative, right? I see -22 minus -5, and I see -5 minus -22. As we saw on a previous slide, subtracting a negative is literally the same as adding a positive. So both of these can be written with the minus negative portion, just rewritten with the plus sign. What I like to do when I'm doing this is I'll just like change. If I see a minus negative sign right next to each other, I just change them to plus plus. But it's better if you rewrite it like this. -22 plus 5 is this one over here. And this one's -5 plus 22. I don't even think we need to like solve these to see that this one's going to be bigger. Because this one, your first number is only 5 in the negative slot, right? It's only a little bit below 0, and then you're adding a really big number, 22. This one, on the other hand, you're way over at -22, like farther into the negatives, and you're only adding a small number, +5. But just for the sake of seeing it, the answer to this one is -17, and the answer to this one is +17. A little relationship there when you switch the numbers. All right, let's move on to the next one. Oh. When Dylan checks their school lunch account, the balance is $56. I'm assuming that means Dylan has $56, or is that like a bill he owes? I don't know. Let's assume it means he has $56. Yeah, because then after buying 8 lunches, the balance is $40. How much does the balance change with each lunch bought? Show whether the change is positive or negative. Okay, well, it sounds like the change is negative, right? Every time Dylan buys a lunch, the balance goes down. So it's changing in a downward direction. That's a negative change. We just have to figure out how much that change is. Well, let's figure out how much the money changed by. Dylan started with $56 and ended with $40. So what was the difference there? What was the total change? 56 minus 40 is 16. So this is the change here. But that change occurred over the purchase of 8 lunches, right? So to see how much it's changing per lunch purchase, we would do 16 divided by 8, and we get 2. But 2 is not the answer, because the lunch purchase is bringing Dylan's account balance down by 2 every time. And so we want to represent that with a negative 2. All right, let's move on to the next one. We got, when Dylan checks our school lunch account, the balance is $56. After buying 8 lunches, the balance is $40. How many more lunches can Dylan buy before they run out of money? Okay, well, we know that each one takes $2 away from Dylan's balance. We figured that out in the previous slide. So if we just do 40 divided by 2, that's going to equal 20 lunches. You could also think of it as 40 divided by negative 2, and that's going to give you negative 20. And these are kind of like the same answer. You just have to know how to interpret them properly. This is saying you can afford 20 lunches. This is saying you can afford 20 changes to the balance, right? Because the changes are negative. Either way, it's like kind of the same thing. But the question is asked in such a way that I think they want the positive answer. Because it says, how many more lunches can Dylan buy? I'm not going to put negative 20. Like, Dylan's not about to buy negative 20 lunches. I don't even know what a negative lunch is. Maybe that's when you barf or something. I don't know. But I think we should put 20 as our answer. All right, let's go to the next one. This says last one, but I feel like it's a lie because this says slide 8 out of 10. So there's probably some bonus ones after this. All right, so we got to match the cards with the same value. So we have to do the math on each one of these cards and match it with the ones that come out to the same answer. It's a lot of work. This is a big homework. All right, so -5 plus -7, that equals -12. So I'm going to write -12 on this over here. And then I'm going to just kind of scan with my eyes and see if I can find another one that equals -12. Let's see here. I think it's this right here. Here, I see 48 divided by 4, which is 12. But then there's that negative sign hanging out in front of it. So that's going to make it -12. So let me drag that one over to my other -12 card. Why won't it let me drag? There we go. All right, and I think I scanned every card and I don't remember seeing any other ones that match -12. So let's try a different match. Might as well just go with this one right next to it. It says -11 minus 3. I hope you, when you encounter any expressions like this, you change that minus to plus negative so that you can see that this is -24. If you were thinking that this was either 2 or -2, then I really suggest you change -13 to plus -13. It becomes more clear that the answer is -24 when you do it that way. All right, and so let's scan and see if we can find another one that's equal to -24. Oh, good, look, it's right next to it. -3 times 8, well, 3 times 8 is 24, but one of the numbers is negative. So I think that's gonna be our match there. I should probably look around and see if I see any of the other ones. Oh, you know what I'm noticing? I missed a -12 one, because look, 36 divided by -3, 36 divided by 3 is 12, but you got one negative, the divisor, or the denominator in this case, is negative, so should have put that one over there. I'm still cruising around looking for -24s though to match this one here. Any other -24s? Yep, look, we've got -5 plus -19. When you're adding negative numbers, they just get more negative. The trick I like to use is to just add them as if they're a positive and then throw a negative sign on the end. So 5 plus 19 is 24, negative 24. All right, we're almost done, it looks like. Here, let's find the value of a different one and start building with that. Here I see negative 6 times negative 4. That's going to equal positive 24. Let's look for other ones that equal positive 24. There's one right below it, actually. Because 12 times 2 is 24, but since they're both negative, it's negative 24. Or sorry, since they're both negative, it's positive 24, I meant to say. And then look here, 15 minus negative 9 minus a negative is the same thing as adding a positive. So this is really just 15 plus 9, and that equals 24. All right, I bet the rest of these three match up. Let's see. Negative 10 minus negative 22, that's the same as negative 10 plus 22. And I could just do that as 22 minus 10 if I wanted to. That equals 12. Negative 14 plus 26, I think that's also positive 12. And negative 3 times negative 4, that's also positive 12. So I think all these will match together as equaling positive 12. That was a tough one. All right, let's look at some of these explore bonus ones. I don't know if I'm going to do them for you or not. I might leave them as just mystery challenge. Let's see. This is an equation puzzle. Fill in the blanks so that each row and column makes a true equation. I could sit here and figure this out if I wanted to. That would take me a long time. I see a button down here that says sample responses. Let's see if we can get a little help from there. All right, so it says the first row is supposed to be 3. Let's see. 1/2 times 3 is 3/2. Oh, and then when you add that to negative 3/2, it equals 0, right? Those are additive inverses. All right, I think I understand this a little bit better now. And so here, 3 times something has to equal whatever we want here, so that when you subtract 3/4, it equals 0. Well, if we want to be able to subtract 3/4 and equal 0, then we want this to equal 3/4, right? Because 3/4 minus 3/4 equals 0. And so 3 times 1/4. Right? You understand that? 3 times 1/4 equals 3/4. And then when we subtract 3/4, we get 0. Okay, let's look at the first column. 1/2 times 8 equals 4. We want to be able to add something and get 0. It's got to be negative 4. Well, this isn't so bad. If I'd have thought about it for a second before cheating and look at those answers, I could have done this. That's what I get. Okay, so here, 8 times 1/4, that's going to equal 2. And we want to add something to get 0. Well, it's got to be negative 2. All right, this is the trickiest one here. We could answer this one by going across the row, or we could answer it by going down the column. I'm going to go across the row here. So negative 4 times 3/4, I know that that equals negative 3. I'm going to try to show you why that's negative 3. So this is 3/4 times negative 4, but I'm going to write it as negative 4 over 1. Well, that equals, I'm just going to multiply top by top, bottom by bottom. I get negative 12 over 4, but 12 divided by 4 is 3. So this is negative 3. And so when you multiply these two things, you get negative 3. And I want to subtract something so that it equals 0. Well, negative 3 minus negative 3 is 0. Any number minus itself is always 0. Let's see if I got that right. Let's check the sample responses again. First row should be 3. Second row should be 1/4 and negative 2. Good. And third row should be negative 4, negative 3. All right, we got that one right. So The answers were down there on the screen for a little second. So if you saw them, good for you. This one, it looks like you just click in the boxes and you have to change them to pluses or minuses. This probably isn't as hard as the other one. And I want to leave some work for you to try to figure out on your own without me giving you everything. So I'm just clicking randomly right now. Don't copy what I'm doing. I'm just clicking boxes. I'm going to leave this one for you to figure out. All right.